Okay, so in the next couple of examples, we are going to be looking at the scenario that was addressed in Table 1-2, number 4. These are when we have equations involving two absolute values. You're going to break those apart, okay? You're going to write U equals W, and U is equal to the opposite of W. So over here on number 46, again, we're going to break this apart into two separate equations. One equation is going to say 2a minus 3 equals a plus 2. The other equation is going to be, one side's going to be opposite in sign. So we're going to say 2a minus 3 equals the opposite of quantity, a plus 2. And we'll solve those. This takes care of the scenario where the stuff inside absolute value bars either agrees in sign or is opposite in sign. Either way, with those absolute value bars sitting there, that would check. Those scenarios would check. So over here on this first one, 2a minus 3 equals a plus 2. I'm going to subtract a from both sides. If I'm going to move my variables to the left-hand side, I'm going to add 3 to both sides to move my constants to the right-hand side. So we have 2a minus a is 5. 5 would work. If you put it back in, mentally check a 5 back in for A. There's one of our answers. Now, before we can solve this other equation, we need to clean up this right-hand side. So I'm going to bring down 2a minus 3. And now on the right-hand side, I have negative a minus 2. Let's get constants on one side, variables on the other. Let's see, I think I will add a to both sides of this equation. And also, again, add 3 to both sides. All right, some stuff falls out, and I've got 2a plus a is 3a equals negative 2 plus 3 is 1. Divide both sides by 3, and so our next solution is 1/3. And that is another value that would check. It's a little bit uglier to check that, but it would check as well. So writing that in solution set form, you would say 5, and also it was a positive 1/3. There's our two answers. Now, over here on number 54, we again have an equation with two absolute values. So to make sure we get our, all of the possible answers, we will say 4d minus 3 equals 3 minus 4d. That's one of them. The other equation is 4d minus 3 equals, I'm going to run out of room here. Let me move that one way over there. And let me move this a little bit over. 4d minus 3 is going to be equal to the opposite of 3 minus 4d. All right. So let's see. Over here on this first one, I'm going to add 4d to both sides. So let's also go ahead and move the constants to the right-hand side by adding 3. So we will have 8d equals 6. Divide both sides by 8. And d is equal to a fraction that will reduce. 6/8 reduces to 3/4. Okay? Now, over here on this other equation, let's run the negative through first. So we're going to be solving 4d minus 3 equals negative 3 plus 4d. You got the same thing on one side as you do on the other. If you don't recognize that, go ahead and subtract 4d from both sides. the variable parts fall out, leaving us with a true statement. Now, remember what happens when variable parts fall out and you're left with a true statement? That means you have an identity, and all values of D will check, okay? So you would say you have an infinite number of solutions. And so your solution set is going to be the set of all real numbers. And that's really all you need to say. It's all real numbers. You don't have to put and 3/4 because 3/4 is included in that as well. So all real numbers is our solution set.